All right, so my name is Bill Venners, and I'm here to talk about testing, a very exciting topic. We have Eric Torrebara in the front row here, and Ricard Nilsson over there. They're keeping distance from each other, so it makes me a little nervous. But anyway, I wanted to give you 7 specific guidelines for how to maximize the return on investment from testing. So what I wanted to start with was there's been this kind of heated debate lately called "Is TDD dead?" Has anybody heard about that conversation? Yeah. So what happened was David Heinemeier Hansson, who invented Rails, at the most recent Rails Conf recently, he railed against TDD. He said, and then he followed up with a blog post that was had a provocative title: "Test-driven development, or TDD is dead. Long live testing." So he and Martin Fowler and Kent Beck decided to get together and do these series of public Google Hangouts. Anybody watch those? Okay. So I thought you might be interested in my opinion of this question of TDD's health. So I wanted to start with that, and this is the 3 guys. The guy at the bottom is David Heinemeier Hansson. He invented Rails. The guy on top, or the guy in the middle, is actually Kent Beck. So Kent Beck was one of the original co-authors of JUnit, and he wrote the book that had the title Test-Driven Development, and he wrote the book called Extreme Programming Explained. So he was kind of behind all this, at least the marketing of this idea. And then Martin Fowler is an influential author. He wrote Refactoring. You've probably all heard of him, and he's kind of a buddy of Kent. And so just before I gave you my opinions, I thought I'd just kind of summarize what these guys said. This is Kent. His basic message was TDD is a question of trade-offs. Martin Fowler said, there's different schools of thought, and I'm with Kent. And David Heinemeier Hansson said, whatever, TDD is dead. And it actually was a little more sophisticated than that. I don't quite do it justice, so I'd recommend you go listen to the conversation. But there was one insight that I got from David Heinemeier Hansson that I wanted to share with you that I thought was useful, and that is if you're ever doing one of these public Google Hangout debates, it'll add credibility to everything you say if you set up the lighting such that there's a halo around your head. So the interesting thing about that is it's actually a sophisticated halo. It's dynamic. He likes Ruby. Ruby's dynamic, so he actually has a dynamic halo. If I go, like, that's what it looks like normally when he's talking. And if I go backwards, backwards, when Martin Fowler was talking, it actually grew in size. I don't know if you can see that. It kind of got larger. And I think there's some kind of subliminal message because when Kent Beck was talking, it shrank. So anyway, I thought that was pretty funny. The whole time through, now you're not going to be able to not listen, and you'll only see the halo. But so enough about halos. What's my opinion? My opinion was basically that I felt extreme programming was too extreme because it would say things like, extreme programmer never writes a line of production code without a failing test. And my opinion was that, well, there's going to be situations where that's not the right thing to do. Because the way I looked at programming is as an economic activity where we're investing a finite resource, which is our time, and somebody's paying us. And so it's actually money that we're investing, essentially. And what we have to do is produce business value in some context. And so you have to make decisions about, do you write a test, don't you write a test, what kind of test do you write, based on that context and based on incomplete information about the future. So you actually have to use your experience and your intuition and just make choices. So in my case, I actually found that writing a test first made a lot of sense, and so I usually do that. I usually do write a test first, run it to make sure it fails, write just enough code to make that test pass, and then repeat. But sometimes I write a test second, and sometimes I don't write a test. So that was my opinion. The other thing that I thought was a little weird was originally TDD meant test-driven development, and at some point it transitioned into test-driven design, and this testing first was about design, not about testing. And I do spend a lot of time thinking about design, but not by writing tests. Design is a different process for me. And for me, writing a test first is really about testing. I just like to write a test, and I want to write them first because then I have to write it, and it actually gets written, essentially. So, so I think that TDD is alive. Because I basically thought it made sense, that sense where it's about actually writing tests, made sense when I first heard about it, and it still makes sense today. So just out of curiosity, how many people, at least some of the time, write a test first, just to take a vote? Okay, see, I think that sort of justifies that position. So, okay. So, one thing that kind of was refreshing by watching these videos or these Google Hangouts was that even though this extreme programming was kind of, I think they said things in an extreme way to sort of generate excitement and market it, which actually worked pretty well. But these days he's mellowed out. I mean, this is one of the things he said early on in this discussion was to make a design's intermediate results testable comes with a cost. It comes with a benefit too, and you have to figure out whether the cost outweighs the benefit. And that didn't actually sound like, that sounded like moderate programming to me, which is consistent with how I look at things. So what I wanted to talk about first was what are some of the costs and benefits of testing. By the way, feel free to ask questions as we go. Just I may move on anyway in interest of time, but yes. You know, I think it's like a hidden question because I can't see who is actually asking it. There you are. Okay. Right. Yeah, I'll repeat the question. Actually, I'll answer it at like 2 slides later because I actually already was planning to answer that. Okay. So just go over some of these things. Certainly, there's a cost to write a test because you have to spend time to do it, right? And that you could otherwise be doing some other thing. And then there's an ongoing cost too. So that's like the upfront cost. But ongoing, you have to maintain it. So there's a cost there as well. But what the main benefit I think you get out of it is you can get your program to work for the most part. I mean, if you actually do the TDD thing and you always write a test first, your program can mostly work. You can get most of the bugs out. So that's a huge benefit for the cost. And you can also, I mean, if you didn't write tests, you might spend more time in the debugger. So some of the time you spent writing tests, you would have spent anyway some other way to get to the quality you want. And it can find problems when refactoring. So that's the benefit of paying the maintenance cost, is that you make a change 2 years from now and one test fails and you realize, I suddenly got louder, didn't I? This part I think they like, but okay. Basically, you make a change and a test fails and you go look and say, I broke that, and you fix it, right? That's actually very helpful because otherwise it'd be pretty hard to make changes, right? The problem comes when you make sort of a big change and 500 tests fail because you've made a major refactor and now there's this huge, huge burden of like fixing all those tests or deciding whether to delete them or whatever, right? So that's a big potential cost in the future. I think it can clarify programmer intent because if you write a test name that says what you're thinking, then when that test fails, I know what was in your head. And if you do the BDD thing where you actually work with someone who's a decider, like a marketing person or a customer, and flesh out what the specification of what the requirements are as a bunch of pending tests, then that's also a very important benefit. I think from my observations of people using ScalaTest, the by far the main use is more developer testing, like unit testing and integration testing and whatnot. But there's also definitely people doing the BDD kind of thing where they're writing specifications with deciders, right? So the other cost is they can take a long time to compile. I mean, they're code, and in Scala things take a while to compile, so they can take a long time to compile and certainly to run. Integration tests can take a really long time to run. And that's not such, I mean, there's an electricity cost on the continuous integration server, but when the developer's sitting there waiting for them to run, that's actually spending money right there. And then lastly, this last one is really like a limit on the benefit. No matter how much you invest in your tests, they can only find your code not guilty. They can't prove that it's innocent, right? It doesn't mean you didn't forget to write a test that would fail because there's a bug, right? So like half the guidelines is about types versus tests, because types can kind of talk about innocence. Okay, so my first guideline is just thinking of programming as investing, and my idea was that whenever someone says always write a test first, that's always the right thing to do, or always write property-based tests, or always write example-based tests, or always write unit tests without mocks or with mocks, or integration tests are better, whatever. It's just, those things are, there's no algorithm like that that will always work. What you have to actually do is think and use your judgment and make choices based on the context and your experience. So the only algorithm that I think really fits is buy low, sell high, which actually works for if you're investing your savings and you do that algorithm, then you'll grow your savings. The trouble is you have to make buying decisions today with incomplete information about the future. So it's the same thing when you're deciding about, what to do with your software project. You have to make these decisions today without actually knowing what's going to happen in the future. So, okay, so that's the trick. So I wanted to give some examples of where I did sort of the opposite of the conventional wisdom. I really want my code to work, so I do write lots and lots of tests. And when someone submits a pull request and there's no tests on it, I usually will go back and probably say, please put some tests on there, because I want to have a regression test and something that kind of says to me that it works, right? Something that finds it not guilty anyway. But this pull request came in without a test, and I accepted it. And the reason is what this one was about was in HTML5 they added some input types to HTML, like email fields. Instead of just plain old text fields, there were now email text fields and phone number text fields and all different kinds of text fields. And so this was added to browsers, and then it was added to Selenium. So people asked us to add it to our Selenium DSL. And so we did, but then it turned out that some browsers don't support them exactly completely. And so when they would run their tests on those particular builds of those browsers, certain tests would fail, and it was annoying. So they just wanted us to make it more loose, that if it says it's an input field for an email, that says, yeah, that's an input field. But otherwise, if it's a text field, that's okay too. That's all. So I looked at it, and I was like, well, that looks right. And I thought about how we would write a test, and we'd have to actually figure out how to get a particular build of Firefox on the different platforms to really do an integration test with this thing. And I decided not to do that because I just didn't think it was worth it. Not that it isn't a good idea, because it wasn't tested, there may be a bug here. But I just didn't think the benefit was worth the cost in that case. And so what I did instead is just code inspection. I looked at that carefully, and I had Chi-Sing, who also helps with ScalaTest, look at that carefully. And then I asked about 100 other Scala developers, starting about 90 seconds ago, to look at it. And so far they haven't found any problems. So in it went. So that one's in. But it's pretty rare that I don't test things, but sometimes I think that's the right thing. So another real simple one is write focus tests with descriptive names. One of the things I try to do in the different styles of ScalaTest is make it easy to do that, kind of to guide people to do that. It's really lightweight to make a test, the syntax is, and it's really easy to type a long-winded test name. And the reason is that when a test fails, it's nice that it's about one thing, so I know that only this thing is what broke. And it's nice if it's actually spelled out in the test name, sort of at a high level what that is. So you can make your test names too long-winded, but you can also make them too short. And I wanted to show an example of one that I consider a little bit too short. The name of this test, and this is from an open source project, not mine, so apologies if someone is responsible for it. But in that test class is actually very pretty. It's actually really pretty code, and it's a very nice test. But what they did is they named their tests after the methods they test. So the name of this test is just essentially. And if it fails, I'm going to have to guess what it means. And I would guess immediately that this is about a method. So it probably is. And I think it's exclusive OR, probably. But I kind of have to either go looking somewhere else, like in the Scala doc, and hope I can find out what's going on there, or just look at the details of the test to figure out what it is. And that would, I think it's better to just say, this symbol should do that thing. So I think it's a nice way to write it. You write it like a little specification. This thing that I'm testing should do that behavior. But you don't have to. You can just say, as long as you tell me what's in your head, caret exclusive ORs or whatever it does. That at least helps me when that test fails. Okay, so that's a guideline. So the third one is beware duplication in tests. So how many people here ever copy and paste? Wow, okay. That's more popular than TDD. Okay, so I do too. And I think the reason we do that is because it's cheap up front. And it's something that I think can have a cost down the road, right? So you save money up front, but you can spend more money later. But if you never, I mean, it depends on the future. It may happen that it actually won't cost any more later, so you kind of have to decide. So usually you want to get rid of that because that's one of those drags on refactoring, I think, when you have a lot of duplication in your test. And it's sort of easier, I think, to make duplication in your test than your production code. But sometimes I think it's the right thing to do. And I want to give you an example. This is how, like, the ratio of production code to test code of ScalaTest itself is about 1 to 5. So we've got this massive body of tests to maintain. And the reason, part of that is because I want to test everything. But also there's some redundancy in there, some duplication in there. Some of it I haven't finished the process of getting rid of, but some of it's on purpose. So I want to give you one example of where I duplicated on purpose. And that is when I deprecate something, I want it to continue to work. So I actually leave the tests for the deprecating thing there to make sure that still works. So that when you upgrade your project, you get deprecation warnings, but everything works like before. But then I always give you a new way to do it. So what I often will do is just copy the tests over. Now I've got duplication, and I just change the parts that reflect the new way to do it, right? So now I'm testing the new way and the old way with twice as much test code, and a lot of it's exactly duplicated. But I don't feel like it's worth it to get rid of that duplication because that would cost money now. And in a year or two, I'm just going to remove the deprecated one and all of its tests, right? So to me, it's not worth it. And so that's just an example of going against the usual thing that you're supposed to do. It's like, don't repeat yourself, right? That's the DRY principle. So I violate it sometimes because I think the benefit is not worth the cost. So one of the things that having a big body of tests can do is when you make a change, sort of a refactor, it can break 1,000 tests. That problem I haven't had that much because I try very hard to keep client code working by not breaking client code. And most of the 99% probably of the ScalaTest tests are against the public API. So I also don't end up breaking my tests, sort of as a side effect. So I really don't have that problem, but I've had this problem where I've made a change and 500 tests broke because the tests were overspecified. So it just happened a couple weeks ago, for example, and that was I wanted to improve an error message, and I did. I just changed it in our resource file, like the first change up there. I made those changes, and 500 tests broke. And the reason is we had hard-coded the error message in the test. And I was like, oh, I didn't notice that. But there's a ton of that in there now. And so what we did is for these ones I changed, we actually didn't just change it, which would have been fast, cheap now. We went ahead and fixed it and made it depend on the resources. You actually go to the resources to grab the string and make sure it's correct. But we didn't fix the other ones. because probably I'll never change them. So if I spend money now to change them, it may never pay off. I make the judgment that it'll never pay off. So if the day comes I do want to change those error messages, at that time we would clean that up. Okay. All right, so I think the other 3 guidelines are about types. Oh, you know what? I forgot to come back and answer your question. I forgot what your question was. Can you repeat it? And this is a sort of a hypothetical question. You don't have a colleague or anything that's okay. So the question was people who are maybe not thinking so much of the cost to the business, but to themselves. I think that's a good question. Yeah, I think what our job is to create business value. And so I would try to, I got loud again. I think this is going to be an important answer, apparently. I would hope that people would, our job is to actually think of how we can create business value, not how we can make our job easier. But I think you can also try and do both, because that would create business value if things are easy for the development team and they're happy. But not just me, but everybody. So I'm not sure I have an answer to how to deal with that. But anyway, let me move on. We can talk about it more after. Sure. So what's a specific example of somebody doing something more for themselves?
So for example, in the case where you've done there,
Yep.
now you know what's the right way to do it.
Yep.
Okay. Now you've got to go in the direction of changing your code over to all this fairly messy. Like someone comes along and just decides, okay, I've got 100 new ones. I don't have time to go
Yeah.
put in that and put the new way of doing it. And they're kind of pushing the code backwards. It's much more likely to cause people to not notice that change that you've done later.
Right. I think what's important is once you decide to spend the cost to make something simple to test, then that's not that hard. I mean, it's not actually hard to do this. It wasn't done. And so like once you get rid of duplication sometimes, now it's easy to not duplicate. So just getting people to do that is all that's really required after that. The real cost is, it's really cheap to make duplicate copies of things and change it a little bit. Actually factoring out the commonality and then getting it easy to not duplicate is the really hard part, I think, because that's the thing that takes more time up front. But anyway, let me move on to types. So I think it's good to transform human errors into type errors, because if something's caught by the type system, you don't need to write a test for it. So that's one way to minimize the cost of testing, is to use the type system so that when people actually make a mistake, they get a compiler error. So I wanted to give you one example of that. It's something I try to do in the library design. There's this thing called prop spec, which it looks a little bit like Rickard's properties trait, where in the Scala doc and buried in there is a description of how to do a test matrix. And what a test matrix is when you have a large combination of like a large number of things that have common properties. Like, for example, in the Scala collections library, there's a bunch of different set implementations, and there's a number of properties that they should all fulfill. What you want to do is actually test that each implementation obeys each property, right? So you can, SQA or quality people will do is they'll make actually this test matrix, and they can be very large. And then what you want to do is hit each cell and make sure that each cell is actually tested. So what you can do is make a table that has fixtures, essentially, of one of each type. So across the top, I have 3 different types of set. And then I'm going to make a table that has an instance of those 3 types of set that comes from these abstract vowels here. Right, so the table is a lazy val, so once it actually gets asked for, it will hopefully have these vowels filled in, right? And so I can make subtypes of set examples. I have one here called empty set, and I just fill in with empty instances. You could make a set with 1 value in it, a set with 10 values in it, right? And so on. So then you have a test class that for each property, that's what the rows are. I just say property and empty set should have size 0. For all empty set examples, set should have size 0. And it'll just run through each instance and make sure that's true, right? And then the other one, invoking head on empty set should produce no such element exception. It just runs through each, for all empty set examples, it checks that, right? And so what's nice about this is if I add a column, what I'm going to do is I'm going to add it to the table. I'll add the abstract val up here. And then if I forget to put it in one of my actually concrete objects that implement that trait, it won't compile. So it forces me to actually test every cell. And if I forget, which is a very easy human error to do when you have this very massive test matrix, you'll get a compiler error. Right? So the thing I find about Scala is that it's, because it has a very rich type system and a very concise syntax, it's really easy to put things in the type system, and it's sort of usually what you'd want to do. And I say usually because putting things in the type system also has a cost as well as a benefit, and you still have to weigh that. Okay. So my next guideline is throw exceptions only at humans, never at code. So way back when, I used to program in C, and the way that we handled errors was that C functions would return a 0 if everything was okay, and then it would return another integer if it was not. And I can't remember anymore if they were negative or positive. But it's like -1 means, ooh, this problem happened, -2 means some other problem happened, -3 means some other problem happened. And so what often happened, because programmers are in a hurry or they don't notice, and it would compile, is people would just ignore the return value and just ignore errors. And then what would happen then usually is the program wouldn't die right away, but the error happened right here, and then the program keeps going, and sometime later it blows up. And what was hard is you had to figure out how to get back to like the root cause. So exceptions were invented to make it fail faster. So if you actually throw an exception instead of returning a number, then if they forget to handle it, it will actually die right there where the problem happened, and you get a nice stack trace to say this is how we got here. Right? So that's the problem it solves. But it didn't actually help you force that people handle the errors. So what the story I heard from Jim Waldo, who is he's now the CTO of Harvard, and he was at Sun way back when Java was still called Oak. He told me the story that he was the one that brought up that if we're going to say this is a type-safe language, that the exceptions of method throws should be in the signature. Because otherwise, even though it's better to fail sooner than later, it's even better to not fail, to actually handle the thing, right? And so you want to force programmers to think about the errors by making it in the type signature. And so this was of course controversial internally, and they ended up deciding to make some of the exceptions checked and others not. So I think actually that was the right idea, because you do want to make errors in the type systems so people will be reminded that they forgot to handle them. The problem was that in Java, with exceptions, it was just not a very good mechanism to do it, right? Because it's just really clunky syntax, and what happened a lot of times is people would swallow them because it was annoying them. They'd actually catch it and not rethrow it, and that was even worse than because now it doesn't ever it does that. It's like going back to the C program problem where it fails much later and you don't know why, right? So that really didn't work very well. But what I think does work well is in Scala, because of the nature of the language, it's really easy to stick it in the return type and then transform the data structures after that. So that's why I say throw exceptions only at humans. What I think in an idiomatic way to use exceptions in Scala is only throw them if there's no chance the program could recover. Because if there's no chance the programmer could recover, some human is going to have to look at the error and fix it. And it's either going to be a software bug. So if the program detects a software bug, the program can't fix that. Some human programmer has to fix it. So you throw an exception, you get a stack trace in the log file, and some human programmer will fix it. It might be a configuration problem. There's a misconfiguration, so it's an ops person that fixes that, right? But it's not the program that can. If the program could possibly recover, you should put the error in a result. Okay, so I want to give you an example of just how you can transform. There's, in this parse name method, there's a string coming in, and if it's empty, that's actually an invalid name. So what comes back is either a valid name or an error message, right? And in parse age is also a string is coming in, and it could either be not a valid integer, or if it's negative, it's not a valid age. So it'll come back with also either a valid int or an error message. So what this parse person method does is it actually gets two strings, and it calls these two methods, and it gets two of these ORs back, and then it just needs to compose them. So you can just, in this one line of code, you can say, if these are both good, give me a person, otherwise accumulate the errors. So there's all different kind of ways to do that, with option, with either, with try, with this thing that I did with this type from Scala Z, or validation, and it's just really it's very pleasant to do in Scala. So I think that's a big improvement over checked exceptions, and that's what I think we should do. So that's output, and the other one I want to talk about was input. What I think it's good to do is minimize preconditions. So let me show you an example with preconditions. So there's a greet method here that takes an integer and requires that it's positive. So there's a require that says the integer you pass me must be positive. So that's one of my preconditions. It's actually the responsibility of the caller to ensure that only a positive integer is passed. And the reason is it's going to print hello that many times, and it's kind of silly to ask. I mean, I don't know what it means to ask me to print it a negative number of times, and it's silly to ask me to print it 0 times, because you don't need to call me to do that, right? So what require really kind of is a test in the production code that's going to detect a software bug. So because it's detecting a software bug, it's actually a good use case for throwing an exception, because the program can't recover if that happens. So it throws illegal argument exception. So if you say greet 0, you get illegal argument exception. And if you say greet 3, you get 3 hellos. But I would also kind of want to test it and say, okay, if this is part of the contract of greet, I'm going to make sure that it does throw a legal argument exception when I pass in an invalid thing. So that's a precondition, and I think when you see requires, you should try to do is see if it makes sense to get rid of it by putting it into a type. So what I did here is I made a does someone have a toast to propose? When I made a positive trait that wraps an int and is going to guarantee that it's a positive number. And so I just have an apply method that takes an int and it actually returns an option. If it's greater than 0, it returns some pos int, which is this private instance, and it's sealed, so that's going to be the only ever instance of pos. otherwise none. And so now I don't have to have require in my example. If I take a pause, it's guaranteed by the compiler to be positive, right? And so when I say pause 3, now I've got an option, so I just say for each greet, and it says hello, hello, hello. And then if I say pause 0 for each greet, it doesn't even call greet, right? So I kind of want to go back to that tests can only prove your code not guilty. It can't find it innocent. How many people think that this proves that basically if this compiles, it proves that pause, that there'll never be a non-positive number passed to greet, as a show of hands? Not too many. Okay, why not? Huh? Reflection. Well, I'm not sure how I could use reflection because I'd have to get the number in there, right? I can't get the number in there with reflection, or can I? Well, anyway, I agree with you.
You can change the value inside using reflection.
Okay, I'll buy that. I never actually had thought of that dastardly, but that's true. You could change it using reflection. What I was going to say is just what if someday somebody adds arithmetic operations on this and forgets about overflow, right? And so someone takes max in and adds 1 to it, and you get a negative number inside a pause. So really the proof that the compiler offers, because there can be bugs in pause, the only proof the compiler really offers is that all calls into greet will only pass in an instance of pause. That's the proof that it offers. How many people agree with that? Okay, more people. So have there ever been a bug in the Scala compiler? So I think what we actually do with these types is they allow us to focus our test. So I test the compiler, and then we kind of assume it works. And now we do act as if there is a proof that nothing other than pause will be passed in. And then we test pause, and then we assume it works. And so now we actually kind of act as if there's a proof that nothing but positive integers will be passed into greet. So that's why I got rid of my require. So although it's true that tests can only find your code not guilty, they can't prove it innocent, types can only prove innocence to the extent they're tested. So these two things go hand in hand. So that is my parting thought. I will open to questions. I just wanted to mention we do have a discount going at Artima for all these different books. Scala Puzzlers is, we just did a new update, and Scala Check just came out final. So does anybody have any questions? Yes? Oh, actually there's a way to do that in ScalaTest. You can say something should not...
Could you repeat the question, please?
Oh, I'm sorry. Thank you for reminding me. Yeah. I wanted you to have him repeat the question, be more colorful.
Okay, so...
But use nicer language this time.
Yeah, I'll try. So when you're doing unit testing, it's possible to do negative testing as well. But when you're doing... When you're using types to verify that something is correct, how do you prove that if they use your type incorrectly, that you get a compile error, because then your test won't compile?
Yeah, I actually have a syntax for that. Let me go there very quickly. You can say in ScalaTest, also Shapeless has a little thing. Well, I mean, God, that's really huge. Let me make that smaller, 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 smaller. Is that too small? It just, like in matchers, it looks like this. So what I do think using the type system is important, so that's why we added these things. They're down here. No, I hit the wrong one, sorry. Not custom compile. Sorry. I'm not very good with computers. Anybody see it? There it is. Checking that a snippet of code does not compile. So you can say something should not compile, and something should not type check. You can, the compile means it may have a syntax error. It will also pass the test if it's a syntax error. If you want to make sure it's a type error, you'd say should not type check. And there's a set of assertions. And there's also one that is should compile. So you can say all those things. Any other questions?
So I think that ScalaTest is one type of example of testing which is quite interesting, but also a little bit isolated from, let's say, work on a business application or some sort of system where you're working on a team. And for example, one issue that comes up, and I'm wondering how you approach this, if you have a legacy system which you still have to maintain and you're hoping to gradually replace this, the legacy system is very poorly tested. Whenever problems come up, it chews up a huge amount of manual effort to test it. And there's an argument to be made, should we go back and sort of backfill tests in order to then make, to give us a way to actually refactor it or to replace it. And this is a very difficult discussion also in terms of cost and benefit analysis. And how do you approach this?
Well, see, I think it goes back to my opinion that I don't know, because it depends on the situation. But you have to weigh the cost and the benefit and make a choice with incomplete information about the future. The benefit is if you write those tests that you have tests now, and when you change things, you will catch things. But that's a huge cost to go back and write a bunch of tests for something that exists. So, yes?
Going further a bit on that question, you don't right now have a syntax equivalent to cucumber. You have behave style tests, but they're all within Scala DSL, not sort of separated either.
Correct. I think the question was, how do I feel about Cucumber? Does that make sense for ScalaTest? And we have feature spec, but it is actually Scala code. So what Cucumber does that's different is it has like a text external DSL that looks kind of like that, actually. And then it has, you make steps to like parsers that interpret that external DSL and executes tests from it. And the idea is that the non-developers can actually collaborate on the text, because that's an external DSL that they can deal with. And it seems like a good idea in theory. I'm not sure how well it works in practice. One of the things I wanted to do is see if non-developers would actually be able to deal with this. And if you don't, like when they're all pending, like before you fill in the tests, it actually seems to, let me see if I can find an example of that now. People have done that. Non-developers, like project managers, have actually written Scala code that is pending tests. But once people start filling in the tests, I think that just becomes very difficult. So I think I want to try to help facilitate that process, but I'm not sure if Cucumber is really the right way, and Cucumber exists anyway. Yep.
Then, when we're moving some parts of the legacy system from one particularly disastrous thing to sort of re-implement very slowly in other things, you can reuse the same test with the same exact text
Yep.
in the two different places.
Oh, okay. Basically what he said, I'll repeat what he said, which is interesting. Okay, and in 1 second I'll just repeat what he said because he didn't have the mic. Was that what he found beneficial was you write all these Cucumber tests in Gherkin, which is the text file format, and then you've used Python to interpret them, and then later you decide to rewrite the app in a different language. You can still use the same input. You can still use the same Gherkin files and just have a different interpreter in that other language. So, yes.
Yes, I have a question around refactorings. I think it actually was part of your description of the talk as well. I don't think you actually talked about it though. So I think my problem with like a lot of like arguments that come for TDD is that you should have tests in place to make sure that if you refactor a piece of code, it still works. Right?
Yep.
For me in practice, this almost never works because the problem is most likely if you refactor a piece of code, maybe you break up a class because it became too large or something.
Yep.
So by definition, your tests are not going to compile anymore. So you have to go back to your tests, rewrite your tests to reflect the new, the new like composition of your objects
Right.
that you have, and this might change significantly. And I don't know, like at last year's GoTo Berlin, Steve Freeman, I think he's credited with like pretty much inventing TDD. I asked him the same question, and he didn't really have a good answer. So I was hoping maybe you have one.
Well, that was really, I touched on that when I was talking about how it can break 500 tests. I mean, that's when you do a major refactor that breaks a gazillion tests, there's a huge cost to fix them. And I don't know how to, that's just, I think that's how it is. I don't know how to actually change that other than minimizing duplication will reduce that cost some, but it's just, that's the cost that you have with writing tests. I mean, you want to actually write as few tests as possible as you can get away with, because that will minimize the cost of major refactors. So that's probably not very satisfying either. Okay, that's a good point. What he said was one thing is you can move, if you move your tests more, instead of unit tests, you're actually moving it to more from the outside system tests. That interface may be more stable than the internal implementation. That's actually a good point. Thanks.
I just want to make a comment because, like, in that example, when you're doing major refactoring,
Yeah.
you have 500 tests which are broken. So normally it means you have changed your interface. But if you think of tests as your specification, as your documentation, so because you're changing your interface, hence you need to change your test too. So I think it's a totally valid example. And it's great that your tests are failing because you need to keep them up to date.
Yeah. Yeah. It's actually, I think, still worth fixing them, but there's still a cost to fix them. In other words, when you make a change that breaks a bunch of tests, they should break, but it's still expensive to fix them as one of the costs.
So why does these type of situations
Yes.
Thanks a lot for the mic. Is of course you can't always avoid these types of situations, but it is a strong indicator that you should rethink how you do your refactoring. Maybe you're doing too much at once.
That's interesting.
That's actually the thing. Maybe you
Okay.
should, only do it in one part of the system first and have a bridge in between while you go about the refactoring.
Okay.
This will slow down the refactoring speed, but will not get you in the messy land where everything is red and you don't know where you are.
Okay.
And after 3 days, you have to bail out or something like that.
You mean you get fired?
Yeah, exactly.
Okay, there's a question behind you, I think, yeah.
Yeah, just on that kind of related point, I was recently working on a code base that didn't have lots of unit tests. So I was working on this specific class. It didn't have lots of unit tests. And I was trying to understand the code. It was lots of quite complex Scala code. I wanted to refactor it to make it easier, but I found it really difficult to do that because I didn't understand the code. It was very complex Scala code. So, and it looks like the idea in writing that was that, you don't need unit tests because, it works, etc. And so I basically had to start writing small unit tests to break down the code into, small methods and understand what it's doing to be able to add the new features I wanted to. And that's kind of the opposite of the case the gentleman just described, that I couldn't actually change the code with confidence because it didn't have unit tests.
Yeah.
So have other people faced this problem, and were they able to fix it in different ways without having, say, to have a test scaffold to help them change it with confidence?
I can say one thing, but if someone has a comment, that might be better, because I usually actually am working on things that have tests. But I've had the problem of working on other, like, client systems where I just didn't feel like, I just was not sure, I wasn't confident that things are tested well enough to know that I didn't break something. And I didn't know, I just had that feeling. I just ended up being really careful, and that kind of was a drag on my progress. Yes?
I quickly wanted to add, one way to avoid excessive breaking of tests when you refactor is that you only test the public interface of your system under test. So if you have a method, You don't test private methods and objects.
Right.
You don't test private helper methods.
Yep.
And if you do that consistently, even if you refactor large scale, you usually only have a few tests that break down. Relatively easy to clean up.
Yeah, that's a good point. What he well, he heard it, so he was on the. I don't need to repeat that one. I would just reaffirm it. I agree with that. Oh. Well, you know, it's actually 10 till, so we should probably. If there's no other questions, oh, one more question. Yeah, why don't you repeat that, because that was.
One pattern that I've used to generate when I'm testing a specific piece of untested code or test code without tests is to use ScalaCheck to generate the inputs to that piece of code. Then you can record the outputs of that specific piece of code, and then you can use that to test as you're refactoring.
Yeah, that's good. That's a good suggestion. Well, did you have a question? Because somebody had their hand up here. Yeah, why don't we ask that one, then we'll quit.
A lot of the tests that I have to work on rely on some amount of state. Like in the example you showed, test that when the TV is on, when you press the power button, it turns off. Problem is that to get the TV into the state where it's on might take a really long time. So I'm really like 99% of my test execution time is just the setup for this one delta. That's like 1%.
Mm-hmm.
And so a lot of the duplication is actually in the code that's executed just for the setup. So I'm wondering, like, what's your suggestions for the situation?
The only suggestion I would have is if you can go backwards, like what people do sometimes, like when web app testing is instead of like creating a fresh browser instance, they actually, like instead of creating a, well, they would measure if it's faster to log out of the server and like reset the existing one or create a fresh one. And then if you would use the faster one. So sometimes it's actually faster to create a fresh one than to log out. But the other thing you can do is do things in parallel, right? But if something really takes a long time, and you just got to manage it. So I think we should call it a day. So thank you very much for coming, and you can ask me. Well,
I think there's a break now, so.
There's a break now. Okay, one more. I hate to disappoint the second to last person. Yes.
Thank you. What about mocking? How to what extent we should mock external services?
Oh, that's a great question. So I actually would point you to